Alright, 7th grade. Today a little trick for converting repeating decimals into fractions. Now if you think about it, if you got 0.7 with a bar over it and you want to find out what fraction that is, right? Converting any decimal to a fraction is to put it over its power of 10, right? If this was just 7/10, we could write 7 over 10, right? But to say 0.777 over, well now we can say that's over 1,000, but then another 7 puts it over 10,000 and another 7 over 100, and it just keeps going on and on. So you got to be a little more clever when you're converting repeating decimals into fractions, and there's a very simple pattern that allows us to do that, all right? If we take something simple like you should have memorized, 0.3 with a bar over it, we know that that equals 1/3, all right? So here's how we're going to be able to do this, all right? I'm going to put a little bit lower because I'm going to have something up here, all right? I'm going to say this fraction is equal to whatever fraction we're going to get for 0.3 with a bar over it is going to be, and now we're going to write this without a bar, 3, 3, 3, 3, dot, 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 all right? So that's our starting point. We take the repeating decimal and write it as a whole bunch of repeating digits, all right? Then we're going to look at that and say, how many digits are repeating? And we see that there's a bar over one digit. So the trick is we're going to take this fraction, whatever it is, and we're going to multiply it by a power of 10 with 1 0 because there's one repeating digit. In other words, we're simply going to write 10 times f. And if I multiply 0.33333 off into infinity times 10, all I've really done is move the decimal point over, and I still have a whole bunch of repeating digits, right? But look what happens. If I do this and I say, well, 10 times f, if f is that, then 10 times f is 3.3333 dot, 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 right? And I'm keeping the decimal points in line because now I'm just going to subtract these two values. And notice what happens. I can do 10f minus f because those are like terms, and I get 9f equals 3 minus 0, 3 point, well, all the repeating digits all subtracted and cancel each other out. So I've got 9f equals 3. I solve for f, divide both sides by 9, and get 3 over 9, in simplest terms, 1/3. What do you know? All right, let's take a look at some others. Here we have 0.18 with a bar over the 1/8. So I want to change this repeating decimal into a fraction. So again, I'm going to write the fraction is going to be 0.18181818 dot, dot, dot. All right, you get the idea. Now I'm going to multiply this times 10, but not 10. That won't help us because I see that there are two repeating digits here. So instead of multiplying by 10, I have to multiply by a power of 10 with 2 zeros. In other words, multiply it by 100. And what happens then is I have 100 times f is equal to, and if I multiply this by 100, I get 18.181818, and so on. Decimal points in line, look what happens. If I now subtract these values, 100f minus f gives me 99f equals 18, and because I moved it 2 places over, all my repeating digits behind the decimal point are all going to cancel out and go away no matter how far into infinity it goes. They're all going to subtract to 0, and what I get is 99f equals 18. So that f is equal to 18 over 99, dividing both sides by 9, the biggest common factor there, and I get 2 over 11, which, if you want to check on your calculators, divide 2 by 11, and you will see that you'll get 0.188888 till it fills up at the end of the screen. All right? So the number of repeating digits is the power of 10 you use to wipe out everything behind the decimal point and leave what's left. Let's try it again. 0.27 with a bar over it, all right? The fraction is 0.272727. You get the idea. Dot, dot, dot. There are two repeating digits, so I'm going to multiply this f times a 1 with two zeros after it, which would move the decimal point over two places, 27.272727, dot, dot, dot. Now I subtract the 2. 100f minus f is 99f equals 27. Why? Because these guys all went away, leaving me these nice whole numbers. So the fraction is 27 over 99. Again, I can divide those both by 9 and get 3 over 11 as the fraction that is equivalent to a repeating decimal. All right? So now you're thinking, well, what happens if you got one non-repeating digit and one repeating digit? Big deal. We start off, f equals 0.1 and then 6, 6, 6, 6, 6, dot, 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 right? It's the 6 that's repeating, not the 1. Since there is one repeating digit, I'll take a 1 with a 0 here, and that will move everything over so that now I get, let's see, yeah, 1 point. That will be 1.6666666. Actually, yeah, there we go. Same pattern. All right. And now when I do the subtraction, I get 9f equals 1.5, and all these guys go away. All right. So I divide by 9, 1.5 divided by 9. Well, you got a decimal over a whole number, so you don't want to do that. I can multiply top and bottom by 10 and get 15 over 90. Right? All I did was move the decimal points over to get rid of the decimal. Divide by 5, you get 3 over, and then 118 equals 1/6. And if you do 1 divided by 6, you'll get that. All right? So the key is you create a subtraction problem. The power of 10 is the number of repeating digits. In this case, it's a little messier, but still can be done. And we get that for an answer. All right. We can do this with percentages as well. 24.24% with a bar over the 24. There's just one extra step, and that is first write the percent as a repeating decimal. And you know that to change any percent to a decimal, you move the decimal point over two places to the left, which gives me a repeating decimal of this. So the fraction 0.2424242424 and so forth. There are two repeating digits, so 100f equals 24.2424 and so on. Do the subtraction, 99f equals 24. F equals 24 over 99, which we put in simplest terms, right? 3 goes into this 8 times, and 3 goes into that 33 times, and there we have a fraction in simplest terms, where we have changed a repeating decimal percent into an equivalent fraction. All right? Same pattern, except one extra step. First, write the percent as a repeating decimal. So that's about all you need to do as far as that goes. Try lesson 110. Change some repeating decimals into fractions in the simplest terms, A to F and 9 to 12. And we'll see you later.